So we're gonna just show you how, or go over how you would run a liquid sample for an infrared scan. We either have the square box or this round little can. This one just happens to have some broken pieces of the sodium chloride plates. These ones still have two that are reasonably intact. You can use either one, and I'll show you that, how you could use the pieces in a second. So normally, and ideally if you had these two right here, you simply get your sample holder, and as previously shown in on how to look at liquid samples or the solid sample prep or the materials you would use, you do use methylene chloride or dichloromethane to rinse these, clean them with a Kim wipe, dry them. When they're ready, what I usually do is you simply get a disposable pipette. You know, whether you actually need to put the bulb on, it's up to you. You only need one single drop. So normally what I would do is take some liquid sample, literally put one drop right on the center of the plate, take the other one, and then just kind of flatten it quite nicely. At this point, I guess you have a couple of options. What some people like to do is take one of these types of plates that can hold your salt plates and squish them together. There's that type. This is another type here. For qualitative purposes in organic, I've never had to bother with that. If you really want to do some fine work for quantitative purposes or things like that, you can play around with that. So what I do is once it's squished together, I simply let it sit in this holder, and this holder will slide into the instrument, and basically that's it. Now the only advice for this is, for many organic compounds, one single drop between these two salt plates handled this way, your absorption is way too concentrated. So what you're going to notice is your absorptions in the infrared are going to be bottomed out near the zero, and they're very, very wide. What you're looking for is if your strongest absorption is somewhere in the ballpark between 20 down to 5% transmittance. You don't want to flatline everything down near 0% transmittance. So if that happens, what I usually do is I would very carefully, and I'll show you if you had gloves on, if there was a real sample in here, I will slowly drag one plate off like that, and I would look at them, and I would look for the one that seems to have a thinner film on the salt plate. And if my organic material is not that volatile, it'll just sit there. So what I'll do is I'll put that with the film facing one way, just the one plate, and I'll put it back in, run it again. If the strength of absorption, if it's still too concentrated, I take it back out, and with a Kim wipe or a paper towel, and I've done this many a times, you very lightly just kind of wipe that. Or some people with their plastic glove will just very lightly wipe it so that you get a thinner film of your organic on there, and then try it again. So with the salt plates in a liquid, that's basically the process, and it's really easy. When you're done, you take these off and yet again rinse them with dichloromethane. And as far as getting stuck with some cracked ones, if you had two that looked really bad, for instance like this, well, the reality is you can still use these, right? It doesn't have to be a perfectly round thing. If you were to make a liquid sample sandwiched in between there, the goal is, so long as the infrared or that red laser beam that you can see in the sample compartment, so long as it goes through some of your salt plate, right? And that's all you're looking for. As long as the infrared radiation goes through some of your sample that's on this plate, whether it's perfectly round or a piece, it still works great, okay?